All right. It is now recording.
I love you, Mom.
All right, here we go. All right, here we go. Simplifying expressions. So we're going to talk about a couple terms today. All right, all numbers and any symbol that represent an unchanging value. This is no big deal, but you should know what a constant is. Constant. The number 7 is a constant. C-O-N-S-T-A-N-T. Number 7 is a constant. Negative 11 is a constant. 3/5 is a constant. 0.279 is a constant. Pi is a constant. Square root of 3 is a constant. Right? So that's the idea of constant, because it's got a certain value. Can a 2 be a 7? No, it's always a 2. It's a constant. Can a 3.5 be anything other than a 3.5? No, it's a 3.5. It's a constant. All right, so it's an unchanging value. But then, what happens when a constant is a multiplier of a variable? Then we have this terminology. And again, it's important that you learn the language of math. I used this word, I think it was an Algebra 1 quiz, had this question in it, and some of the students didn't remember. All right, technically the term is numerical, but it's the second word that I want you to focus on, and that's coefficient. C-O-E-F-F-I-C-I-E-N-T. C-O-E-F-F-I-C-I-E-N-T. So the full name is numerical coefficient, but we usually just say coefficient. So it's very possible a couple days down the road, I'm going to be talking and I'm going to say the coefficient. And if you don't know what that means, then you have no idea what I'm talking about. Rop, I, gop, hop, top. Mop, a, sopo, nop. I, sop. Yapo, you, rop. Nop, a, moppy. I just asked Mason what his name was, so obviously he doesn't know that language, all right? All right? It's not Pig Latin. So point is, it's important to know the language of math so that when I use the word coefficient, you know what I'm talking about, because otherwise you have no clue what in the world I'm saying. And so learn the terms of math. That's why they're on your quizzes. That's why they're on your tests. So when we say coefficient, we mean a constant that is a multiplier of a variable. So we already know that a 9x means a 9 times an x. Now we already know that aspect. The 9 is the numerical coefficient, or coefficient for short. So I highlighted them, I color-coded them, so it's easy to see. The second example, the -2 is the coefficient. And the third example, the 1/3 is the coefficient. Right? And the fourth one, the -3.8 is the coefficient. Okay? Pi can be a coefficient, etc. Any constant, generally though a number, and so coefficient. All right, another thing with terms is the idea of terms are expressions. We talked about expressions yesterday. There are a bunch of numbers with operations. Can be an algebraic expression as well with operations. And terms are expressions that are separated by addition. Addition. Now, again, I'll put in parentheses with quotes because I don't like to think in terms of subtraction. But just so you understand, that's kind of included, because subtraction is the same as adding the opposite, right? So, but lest you don't think if there's a minus sign it's not a term, then let me do that. Okay, so what we want to do is go through, oh, I love my creative numbering system. This should be a 4, right, obviously. Okay, so as we go through, let's see if we can figure out how many terms are present. Let me Get rid of that for a while till we get there. All right, so remember, addition is the separator of terms. So does this make sense? If this is the dividing line, we have the first term here, and now we have the second term there, and there are two terms. And here's an important thing in math. We have to learn and understand that those two are tied together by addition. The x and the 8 are, you almost want to think, inseparable. They're a group. You know, if the x is a 12, then together they equal 20, right? If the x is a 7, together they equal 15. They're tied together. There are two terms there, the x and the 8. So when you look at our second example, which represents, by the way, what's the name of the 3? The 3 is a, talk to me, the 3 is a, right? Say it to help you remember it. It's coefficient. So somebody tell me what this means, number 2. I mean, what is it telling you to do here? What is it telling you to do? Matthew?
3 times x times y times z.
Exactly. 3 times x times y times z. So how many terms are there, class?
4.
Agree? How many say 4? Anybody disagree? Uh-oh, there's always one. Abigail? How many terms do you think there are? I said there's always one, meaning always somebody disagrees. How many terms do you think there are? 0. She thinks there are 0. Anybody agree with 0? Okay, we got a couple. Somebody converted already. Anybody have anything else? So far we have 4 and 0. Zach? 1. Zach thinks there's 1. Anybody else think there's 1 with Zach? Oh, Daniel. Daniel's with him. You just giving him support, or do you think he's right? Don't know. Alex, something else? 3. All right, so we have 0, 1, 3, and 4. Okay, so let me help you. Let me debate the cause on this one. Here's how we're going to debate the cause. Terms are expressions that are separated by addition. Shh, don't say anything. So the invitation's open. Anybody want to convert? Let me see your hand if you want to convert. All right, what are you converting to? 0. 0. 0. 1. 1. 0. 0. 1. 0. 1. All right. So we definitely converted to binary. All right, we're either a 0 or a 1. All right, one of those is correct. And obviously the other is wrong. So who's right and who's wrong? Let me ask you this, you 0 people. If it's 0, how do you ever get one term? If this is 2, isn't that 1? Right? If x plus 8 is 2, what's just an x? 1. All right, anybody want to convert now? All right, you should convert. That's one term, right? One term. It's all one thing. It's all multiplication. All right, let's get to the next one. 3, most people get, don't say anything out loud yet. Get an answer in your head. 0, 1, 2, 3, 4, 5, 6, 7, etc. However, how you want to go. How many times are there for number 3? On 3, give me your answer. Are you ready? Here we go. 1, 2, 3.
3.
Okay, and hopefully you're going to say uno, dos, tres, right? 3 terms? 3 terms?
Yeah.
All right, last one. Let's see if you can get number 4 correct. Don't say anything yet. How many terms are there with number 4? And class, there are 2. Right, there are definitely 2 terms there on number 4. All right, dos hermanos. No, I mean those terms. All right. Quiet, please. All of that leading us to this key thing. So the other day we did distributing. Now we want to talk about like terms. So now we should understand what terms are. So the 2x over 5 is a term. The 1 is a term. The 2a is a term. The negative 3b is a term. The 7 is a term. Like terms are terms with the same variables, and those variables have the same exponents. Exponents. Now, technically, every just number without any variables is a like term to any other number. For example, can you add a 3 and a 7? Yeah, you get 10. That was like second grade, right? So no problem. But when you start having letters meaning variables, we've got to know what like terms are. So here are a couple examples. The first example, you have a 2x, a negative 7x, a 5.2x, and a 1/3 x. All four of those are like terms. Each of them have the same variables and x. And in each case, the x is to what power? What power is the x to? Say it if you know it. 1, though it's not shown, right? We don't show ones. So each of them have an x to the first power. They're like terms. You look at the second one. Again, this one I have 3 terms listed. 4x squared y, negative 3x squared y, 2.6 yx squared. Wait a second. Are all 3 of those like terms?
Yes.
Uh-oh, controversy again. How many say yes? How many say no? We have controversy. Anybody want to debate their cause on this one? Anybody want to tell me why you think they are like terms or why you think they're not like terms? All right, either way. Alex, which way are you? Yes or no?
No.
And why are you no?
Because the values are all different.
Okay, so the values are all different, okay? All right, and who's going to debate the yes cause? Brett?
The variables are the same, but the order is just switched.
Okay. Wait, don't keep debating. This isn't like the presidential debate, all right? You have to wait your turn to debate. Anybody else want to convert based on those 2 things? What are you going to? Yes or no?
Yes, because...
I didn't ask you to debate. I asked you whether you were converting. All right. So I'll do one more. Anybody else want to debate the no cause? Anybody else want to debate the no? Anybody want... John?
I think it's no because yx squared is not the same as x squared y times y.
Okay. All right. And anybody want to debate the yes cause? Josias.
Because they both have the same variables and also both have the same exponents.
Okay. Anybody want to convert one last time? So here's how I would have debated my cause. I would have said this. First off, I'd have started out with Josias, and I would have said, both of them have the same variables, and both variables are to the same exponent. The x's are squared, and the y's are to the first power. And the commutative property allows us to change the order. Therefore, they're like terms. And the answer is, yes, they are, right? X squared, x squared, x squared, y to the first, y to the first, y to the first. Commutative property says we can change the order, right? Okay, there you go. They are like terms. They are indeed like terms. Well, that brings us to this key thought. Only like terms can be added. And if you want to think of subtraction or subtracted, only like terms can be added. Come on, go up. So only like terms can be added, and that's the key, and that's what you have to remember. So, how do you do it? Well, the coefficient tells you, just like we've done all along, how many of each you have, right? The coefficient tells you how many you have. So all you got to do is, oh, it keeps changing on me, just add the coefficients. That's all you got to do. So I want you to really focus in to what I'm going to say here. Take your blue and do what I do and watch, all right? Here it is. This simple. 3 of them and 5 more of them is what? 8 of them, and what are the thems? X's, right? 8 X's. I'm just adding up how many of them there are. How many X's do we have? We got 8. 3 of them and 5 more of them, 8 of them. So in the second example, what would you get there? Don't say anything out loud. We got to figure out how many n's there are, right? We got to figure out how many n's are there. And class, the answer is?
Negative 3n.
Right? 4 of them minus 7 of them. Notice I always include the sign. Leaves me a negative 3 of them. Do you concur?
Yes.
Do you know what concur means?
Sure.
Why are you agreeing to something you don't know what it is? All right? You just agreed to give me $100. Thank you. That's what concur means. By the way, concur means agree. All right? So you were agreeing to something you didn't know you were agreeing to. All right. You didn't know you were agreeing. All right. So let's go ahead and do that with 3. Don't say anything out loud. Go ahead and they're all like terms. Do you agree? So we can add them. So add them up. What do you get? Don't say anything. Not everybody will get this one correct. So be in the group that does get it correct, because not everybody will. I'm going to show you on this one the technical way, but like terms are so easy to add. I'm not big on you doing it the technical way, but I will show it to you. All right, on 3, give me your answer to number 3. All right, here we go. 1, 2, 3.
Negative 7y squared.
Quiet, please. So I heard negative 7y squared and negative 8y squared. How many had negative 7y squared? How many had negative 8y squared? And how many have something else? Okay, what do you got, Zach?
I have negative 7 times y to the 6th.
Okay, negative 7 times y to the 6th. Yes, ma'am?
I have negative 7 today.
Okay. What else? Raina? Okay, very good. Here's what's happening for some of you. For some of you, you are confusing adding and multiplying. So don't write anything, but just think for a second. Just the y's. If I had y times y squared times y squared times y squared, that would be y to the 6th. But am I multiplying?
No.
I'm not multiplying. I'm not doing that at all. So it's definitely not anything but y squareds. We're just trying to figure out how many y squareds do we have. So again, I have a negative 3 of them. Technically, this is what they want you to do. Write the negative 3 coefficient. Now I have negative 4 more of them. And what is this last one?
1.
A positive or negative 1?
Negative
A
1.
negative 1 of them. Now again, in my estimation, we can do this in our head, right? Because I'm telling you to add up negative 3 of them, and a negative 4 of them is a negative 7 of them, and a negative 7 of them and one more negative of them is a negative 8 of them, right? So we end up with a negative 8 y squared. We're adding up how many there are, Josiah.
Like that, like how you just did it in our homework. You want us to draw work like that.
Only if the book forces you to. Let's go to the back and let's get some more of the... Whoa, what happened to my second page? All right, so let's keep rolling on. Let's go ahead and try to do 4 and 5 and stop. Don't go past, all right? Just do 4 and 5 and stop. Remember, you're trying to add like terms. You got to do that for number 4. You got to do that for number 5. Add like terms. So do 4, do 5, and stop. Once you're done, look up so I know you're there. 4 and 5 and stop. Don't go past 5, please. All right, somebody raise your hand and tell me the answer to 4. What's the answer to 4? John, what do you got? Negative 8, what? AB? How many agree with John? Negative 8 AB. So let's take a look here. 5 positives of them and 9 negatives of them leaves me 4 negatives of them. And remember, a BA is the same as an AB. It is a like term. Negative 4 of them and 4 more negatives of them is a negative 8. And the way you always leave a final answer is your variables in alphabetical order. Okay, that's the proper way to leave a final answer. Though negative 8 BAs is the same as negative 8 ABs, the best answer is alphabetical order. That's standard operating procedure. All right, so how many got that one correct? Because again, commutative property, those are like terms. They have the same variables. Variables are the same exponents. Now 5, let's see what happens there. I would expect probably 10 of you to miss number 5. So who can raise your hand and give me the answer to number 5? Kelsey, what do you got? 10N, how many agree 10N? Just a couple. Let's find out who's got something else. Raina, what do you have for 5? Negative 10N, how many agree it's negative 10N? Okay? Emma, your hand wasn't up either way. What do you have?
I had
10N. All right, so you want anybody have anything other than 10N and negative 10N? Michael?
I got negative 18N plus 8.
Really? Anybody else have negative 18N plus 8? Huh? You mean you guys actually did what you're supposed to do and you actually added like terms? Like a negative 7 of them and a negative 11 of them is a negative 18 of them, and I certainly can't add an 8 with an N, right? 8s are 8s and N's are N's. Are 8s and N's like terms? No. So it's negative 18N plus, does that make sense now that you see it? All right, and that's what I knew about 10 of you would get it wrong because that's normal. But you got to be applying the principles that you learn. You're looking for like terms. You're only adding like stuff. So here's what I want you to do on number 6. In green or blue, add one set of like terms and use a different color to add the other set of like terms because there's 2 different sets of like terms, right? And see what you do on number 6. Don't do 7 yet, just do 6. Don't do 7, just do 6. Theo, what do you got for 6?
13X minus 10Y.
So 13x, and I think you said minus 10y. Anybody else get 13x minus 10y? You would be all the correct ones. 2 of them and 11 more of them is 13 of them. A negative 4 of them and another negative 6 of them is a negative 10 of those, right? 13x minus 10y. Does that make sense? Right? We're adding up the like things. We're adding up the like things. Okay, try 7. What do you get with 7? What do you get with 7? Learn now. We're human beings. Human beings learn. That's what school's about. Make adjustments. Think about what's going on. Look up when you're done so I know we're ready to roll. Madison, what do you think? I think I heard 8z squared plus 5z. Is that what I heard? How many agree with Madison? Okay, you would be the correct ones. Because Madison said a negative 3 of them and a positive 11 of them is a positive 8 of them. And she said, though they have the same variable, the variables are not to the same exponent, and therefore they are not like terms, and I can't add them. Right? Right? So, and that's correct. That is the answer. 8z squared plus 5z. Right? Can't go any further on that because they're not like terms. Hey, they're both z's, that's good, but the exponents don't match. It's got to be both. Okay, variables got to match, exponents have to match. Okay, couple examples left. All right, see if you can get 8. Let's do 8 and 9. Let's see if we can get 8 and 9. I think part of 9 is hanging off the screen there for me. All right, there we go. Let's do 8 and 9. Last 2. Finish strong. Let's see if you can go 2 for 2 at the end. Try to go 2 for 2. Again, I would use the box method. Every time I've showed you one, I keep showing you how I'm boxing them in, right? And I like using different colors for the different terms. Remember, if you're going to do homework with color, do not use what color?
Red.
Don't use red, all right? Because red is what we grade in. All right, let's go 2 for 2. Come on, you can do it. 2 for 2. So again, this is the way I do them. A -7 of them, and a +1 of them is a -6 of them. A -6 of them and 5 more negatives is a -11 of the ends, right? How many so far? You're good. Let's finish. A -3 of the p's and +2 of them leaves me a -1 of them. And if I really want to show that best, I won't write the 1, right? Because do we write 1s in front of letters? We don't. If we really want an excellent answer. But if you got -11n minus 1p, good, you're understanding, right? How many at least got that, -11n minus 1p, okay? So let's look at the second one. There are no other x squared, so that's just going to stay, right? Nothing to add that to. It's lonely all by its lonesome. 10 of them plus 5 of them is 15 of them. 15 positives and 17 negatives leaves me 2 negatives, right? And 2 negatives and 3 more negatives, 5 negatives. Do you guys see why I taught you how to add positive and negatives in your head? And why I taught you that way? How many got that one correct? Great. Awesome. Awesome. All right, so your homework, look, unless the book tells you to do it with the parentheses, I'm fine with that, but show me boxes and, that's all you need to do, okay? All right. Do well with it.